All right. Hello, everybody. Welcome to the last session of this conference. Awesome. You made it. We made it. 2 days of very intense learning and industry exchange. I hope you're not too tired, too exhausted yet, but don't worry, it's only one more session, and then we're done. I'm also fully much aware that the only thing between you guys and beer is me. So we're gonna make this a light and breezy talk and explore what comes after Git. Who am I? Hello, I'm Schabetsberger, but you can simply call me Chris. It's probably a lot easier for you. I'm a freelance software engineer and software architect coming from the wonderful country of Austria. I'm actually doing mostly C#.NET stuff nowadays, but please don't tell that the organizers, otherwise they won't invite me back again. And I really loved it here. It's an awesome conference. Yeah, I'm also a .NET meetup organizer in my local city, but it's not very interesting to you. And I'm on social media, so if you want to reach out to me afterwards, I'm on Blue Sky, I'm on Mastodon, I'm on LinkedIn. Feel free to ping me wherever you want. Enough about me. Let's talk about version control systems. Is anybody here that does not use a version control system, like at all? Nobody. That is wonderful. You would be surprised, I know at least 2 companies that don't use any kind of version control system. I don't know how they survive, but apparently they do. Who of you does not use Git as their main version control system? All right, looks like everybody. That almost aligns with the data we saw in the Stack Overflow survey of 2022. I haven't asked that question since because, well, the result was very, very clear. So Git has a market share of almost 94%. Some people are still using Subversion, some are using Makuro, and then there's a small part here that apparently doesn't use a version control system at all. We have to note here that this is the overall response, so including people who are still in education, and that makes sense. So if we go over to the professional developers tab, and you can see that Git has an even greater market share, and basically almost everybody uses a version control system. Also, I'm really questioning if you should call yourself a professional developer if you don't use any version control system at all. Good. So I think we can agree that Git is the main superpower. But it wasn't always like that. So Git didn't magically become the dominant version control software in our industries. Neither was it the first one we had. So we can see a lot of different version control systems here in this word cloud, basically the history of the past 50 years. And Git built up based on good work, hard work, and reputation through the past 20 years to become the dominant system that we know and love, or hate sometimes, nowadays. So the question is, what will it take to replace such a dominant industry player? To predict the future, we need to understand the history. I don't have a TARDIS with me here today, but I want to take you on a little time journey back into the 70s, when we got a first standalone version control system. And that one was Source Code Control System, SCCS. It was developed by Mark Rutchkin, who worked at Bell Labs back then, and it absolutely dominated the industries well into the 90s. And if it'll take a look at the characteristics, it only supported locking, it only supported files, so no file set. It only worked locally, no collaboration tools, no network capabilities whatsoever. And still it dominated our industry for 20 years. So it takes an immense amount of effort to break such kind of dominance. SCCS was so important that it even became part of the single Unix specification. So basically a specification that all Unix systems out there follow. And yeah, it was very hard to get rid of. On the right side here, you can see some kind of console log, simulated console log for all the version control systems we're going to check out now. I will not go into the detail because we don't have too much time, but feel free to check them out a little bit. You might recognize reused patterns and reused comments down the line. The next one was RCS. already 10 years later after SCCS. And it took even till, I think, 1986 or something, till it actually gained traction out there, because previously it was very closed, and then the open source community built basically the same thing, it reverse engineered it, and only then it became freely available. Yeah. It had similar characteristics to SCCS, so it worked the same way, only local, only locked-based, no collaboration whatsoever. It worked a little bit differently than SCCS. It has a thing called reverse delta, so they always kept the latest version ready available, and with each new change, they basically calculated on how to get the previous one. That apparently should have sped things up a little bit. The original SCCS creator says, nah, that didn't really do much things. We don't really know, or at least I don't really know who is in the right here. Also, it doesn't really matter anymore. Another jump ahead into the next decade, we got the control version system, CVS. And that one was also already quite popular. Linus Torvalds described CVS in a recent interview as basically a wrapper around RCS. So we're now in the generation where collaboration becomes a part of version control systems. We are now having the first version control systems that have or support centralized client-server modes, so you can work together on one project with your coworkers. It had a merge before commit strategy, something that we don't have this way in Git nowadays, and it was not atomic. So if an operation went wrong, it could corrupt your repository. Not really awesome. Another jump ahead, another decade ahead, we finally get to BitKeeper. This is the last jump we're going to do, and we're now in the Neolithic Stone Age of version control systems. But it was awesome. It was a great innovation, because in the year 2000, BitKeeper was released. Being a proprietary software, it actually cost a lot of money, so their main target group was more in the enterprise segment. I think a license cost around or under $2,000, which is really not that cheap. But they had free licenses available for open source projects. And so the Linux kernel adapted BitKeeper in the year 2002 and used it all the way till the year 2005. The main selling point about BitKeeper was that it was the first fully decentralized version control system. Yes, there were others, as we saw with CVS or with Monotone or Arch. They all supported some kind of collaboration with a client-server mod, but fully decentralized, as we know it nowadays from Git, according to my knowledge, BitKeeper was the first one there. It was also the first one that supported file sets, or one of the first ones. So you could check in multiple files, something that we take for granted nowadays. But back then, the very early beginnings, you could only check in single files. Good. Anything I forgot? Yeah. It supports a commit before merge strategy, something that we see and have in Git nowadays. And internally, BitKeeper reused data structures from the very first version control system, SCCS. Good. In the same year, we also got Subversion. Some people loved it, many hated it, but it was a fine tool, and it was the most compatible successor to CVS, probably one of the reasons why it was also quite popular. It also had a merge before commit thing, so in comparison to BitKeeper had commit before merge. The problem is, we are talking about a time where developers were afraid of branching. Because if you create a new branch, you now have two versions of your software. And how will you ever integrate that back together? Mind blown. Today, no problem at all. I think people were just a little bit too scared back then. But so basically, everyone I know that used Subversion, they used it with locking on the centralized file server, which is especially fun if your coworker locks a file and then leaves for a 3-week holiday. Because then you usually needed some kind of admin to remove that lock and all that kind of things. It wasn't really nice. But it also supported file sets. It had atomic operations, so very low chances of corrupting your repository. And then we get to the main player here tonight. That is Git. So Git was created in the year 2005, and none other by the Linus Torvald, that also, as we all know, created the Linux kernel. Everything began with the adoption of BitKeeper back in the year 2002. Because BitKeeper was proprietary software, and that wasn't well received by everybody in the free as in speech open source community. So this was a ticking time bomb. It was only a question of time till this would become a problem. And it did. In the year 2005, an Australian software developer reverse engineered BitKeeper, which apparently wasn't that hard because it reused the data structures from SCCS, and really released a software called SourcePuller. And the BitKeeper developers didn't like that at all. They were very angry and basically stopped handing out free licenses to open source projects, even though their CEO was a big, heavy supporter of open source. So BitKeeper argues that this Australian software developer violated the license. He argued against it. He said he never agreed to that license. Pick your fight. I don't care. Good. So Torvalds tried to mediate between the two parties, but he was not successful. They couldn't find a common ground, and that's basically how Git was born, because the Linux kernel needed a new version control system. Linus Torvalds, in a very recent interview to the 20th birthday of Git, said that he absolutely hates CVS and basically everything that is built around that. BitKeeper wasn't an option anymore. It was the only option, he said, that didn't suck. So he created its own one, and he wrote the first version of Git in 10 days. At least, like, the code part. The discussion was ongoing for a couple of months. Good. Also in the same year, we got Mercurial. So Mercurial is still used some parts nowadays. Maybe. We don't exactly know, because one of the biggest Mercurial user is Meta. At least they said it like that. In the year 2014, they released a big blog post on how they patched and modified Mercurial to make it work on scale for them, being written very modular in Python, so they could easily extend it, something that they say they couldn't do with Git. I'm not sure if they're actually still using this, but it is very likely that a lot of their core systems will still run on some kind of Mercurial patched version. And we also saw it in the Stack Overflow data. There are software developers out there that still use Mercurial. From characteristics, it's not very similar. It's somewhat similar to Git, but it does some things differently, as we will explore in the upcoming minutes. Good. So much about the setup. But how did Git become so dominant in our industries? Why was it not Mercurial? Why was it not Subversion? I think there are two reasons. The first one is kind of obvious. It was not only used, but it was invented by probably the biggest software project we have in our industries, the Linux kernel. So that gave them a big head start in adoption. It spread the word that there is this cool, new, shiny thing of version control system that you could use for your software project. And I think that just gave them a very, very big head start. The second reason is probably GitHub, or in generally, free hosting of source code. We had that before a little bit, but I think GitHub really pushed the Git part of it in this case. And we saw other platforms following. We got GitLab in around 2007, 2009, something like that. And then other application lifecycle management tools like Bitbucket that originally used Mercurial added support for Git. Same thing for, nowadays it's called Azure DevOps, pick whatever you name you want. I think Microsoft changed it like 7 times. They used the Team Foundation version control previously, and then later added support for Git. And that basically cleared the path for infinite Git dominance as we know it nowadays. And 20 years now later, we can say, congratulations, Git, happy birthday. But what happened the last 20 years? Why is Git still so dominant? We don't often see software running that long. I mean, we see it, but we usually hate it with a passion, call it legacy, and want to rewrite it instead of modernizing it because, yeah, it's often a pain. Well, I think the reason is because Git is really, really good as a version control system. It does one job, and it does the job bloody well. And that is something I really respect about it. And they are still having regular releases. Git version 2.50 was released just a couple of days ago this week. And they're all the time improving stuff, adapting the storage and the algorithm to make them even faster and more efficient. So it hasn't become this big ball of mud that we usually see in a lot of legacy application softwares. I mean, Git is not really legacy because it's still awesome. Good, but what happened since Git was released? In 2006, we got Fossil. Fossil hasn't really gained any meaningful market share since then, but it was developed by Dr. Richard Hipp, the creator of the SQLite project. And so there's one famous project, at least, that uses Fossil, and that is SQLite. It also includes some other stuff, like a bug tracker and a wiki, all very tightly, nicely integrated. So it has its features, but it's probably more suited to like smaller development teams, because I think there are like 4 people working on SQLite, so we don't have really much data if it would, how it would compare to a big project like the Linux kernel. Good. In 2015, Pichul was released, and that would have been quite interesting, because Pichul tried to solve the performance problems that drugs originally had. We didn't talk about drugs so far, because we had to skip over a lot of the version control systems in the history, but basically, it was released a couple of years before Git. It had performance problems, and therefore also lost the battle of version control systems. Pichul works quite interestingly because it doesn't use snapshot like Git or Subversion does. It works with a theory of patches, so they always only save like the difference of it. Unfortunately, Pichul seems to be mostly inactive nowadays. So it was started in 2015. When I started the preparation for this talk, the last change they published was in 2024. Till now, till this conference, they finally have 2 new additions this year, 2 somewhat small changes in their, not sure if they also call it repository, but let's call it repository. But there is a version 1.0 minus beta out there for quite some years, and not much development ongoing, so I don't think that this one will lead anywhere. However, if you're interested more into those 2 version control systems, there is an awesome talk from Voxxed Belgium by Hanno Embrechts, I hope I pronounced that right, and he basically explored those 2 options and demoed them, which we were gonna not do here today, it would be redundant. Good. What I want to talk about are the 3 newest adaptations that just came around the couple last years. Anybody ever heard of Jiu-Jitsu? Oh yeah, 2 hands, wonderful. Anybody ever heard of Sapling? Okay, 1 hand. And anybody ever heard of Git Butler? Oh, the most hands, wonderful. Good, let's start in order, let's talk about Jiu-Jitsu. So Jiu-Jitsu was created by Martin van Zwijkberg. He's an engineer at Google, and he works at, surprise, surprise, version controls. Because Google famously doesn't use Git for their core systems. Instead, they are rolling their own thing, just like Microsoft did, just like kind of Facebook is doing with their butchered version of Mercurial, let's call it that way. And the special thing about Jiu-Jitsu is that it separates the version control system from the storage backend. So for all we know, you could be using Dropbox as a backend if you want that. I don't recommend it, but apparently it should be possible. Of course, Jiu-Jitsu supports Git as a first-class citizen, as a first-class backend to use. It has a very mentally different model compared to Git. So there are no explicit indexes, there is no staging area, and Sorry. Yeah. And it, by default, uses anonymous branches, just as in Mercurial. So you don't need to find a new branch name each and every time. Also, conflicts are treated differently. So in Git, a conflict, a merge conflict, usually means panic. Because you need to resolve it right now, right at this place. You can't do anything till you resolve that conflict or till you canceled the operation that you wanted to do. That is different in Jiu-Jitsu. It treats conflicts as first-class citizen. So you can try to merge something, generate the conflict, and just continue doing stuff. So you can check out another commit instead and compile it, start to do whatever, and you can resolve that conflict later. They call it like first-class objects, so they have it in a data model that they can support this kind of things. Also, a special thing about Jiu-Jitsu is that it is working with a working copy as commit. That is very different from how Git does things, because in Git, usually you do your changes, and then you commit things. In Jiu-Jitsu, you create the commit, and everything you do is automatically part of that commit till you create a new commit. And that is very different how Git does, on how Git does stuff, but it allows for a much richer project history. Let's be honest. Who of us didn't have changes not committed in his working directory, and then you change something, and then you would have liked to go back to that previous thing? Yeah, thanks. Thanks for being honest. It happens, and Jiu-Jitsu tries to solve this problem a little bit. So we're gonna do a quick demo of Jiu-Jitsu. I'm gonna be honest up front, we can't check out all the features. Jiu-Jitsu alone is basically at least a half-day workshop to wrap your mind around the mental model. But I think we can explore some things. So let me quickly change the screen sharing. Whoop. And then we're on the console. Is that big enough? No. Okay, I feared that. We can make that a lot bigger, I hope so. It completely fucks up my prompt. Ah, damn, I tried to not swear. Good. So Jiu-Jitsu is first and foremost a command line tool. Actually, it's only a command line tool. I think that is one of the biggest drawbacks, because as much as I like my terminal, in the end, for some stuff, I prefer a UI. If you ever did Git, an interactive rebase with Git in the terminal, I think you know what I'm talking about. I think it's a lot nicer on the in the UI. Good. So our command line tool is called JJ, stands for Jiu-Jitsu, hopefully. And then we can init a new repository as soon as we're in the correct folder. And if we call JJ-log here now, we can already see that there are two commits here. First one is this ZZZ000 root commit. So every Jiu-Jitsu repository starts with this kind of root commit. And then you can see we already have a commit here, even though we didn't create one. So it will automatically create one for you. And it is empty and has no description set. So let's set a description. We can do this with JJ describe. And then you can, just as in Git with -m for message, you can set the message of the commit. And if we call JJ-log again, then we can now already see our commit message. So you do not need to wait till the end. You can set this right from the beginning. And it absolutely makes sense if you think about software development. Because most of the time, you start with a ticket. A ticket has a header and title, a description. Use it. Good. Let's add some changes. We're going to create a README file here and say, hello, Voxxed days Luxembourg. Good. And if we execute JJ-log now again, we now can see, okay, this empty thing here is gone because we now have content in there. And the interesting part is here, we can already see at the right, in the right column here, that we have hashes here. And this hashes changes. So obviously, because we did change something, we set a description for our commit. We added, just added a new file there. So it automatically is committing the things that we're doing. Not really automatically. You need to call some kind of JJ command, like JJ log, JJ status, whatever. But then it will do automatically these things for you. The interesting part is, if you look in the first column here, this is the so-called change ID. And that one stays the same. So we have the change ID throughout of our commit, even for the content changes. And the awesome thing about that is if you go deeper into Jiu-Jitsu, it allows you to do some really awesome things. Anybody ever did an interactive rebase with update refs and enabled in Git? It's basically that, but on steroids. And it's really awesome because it recognizes changes. One of the things that sometimes can be annoying in Git is if you're doing cherry picking, because you have the same change, but the hash will be different, because it is a different commit chain. Git is just blockchain on steroids, too. And by the way, probably one of the only things where blockchain is an actual valid use case. So this works differently because you have this change ID, and so it stays the same even among different branches, which is really, really awesome. Good. Let's do other things. We're going to create the new commit. So we have a new commit here. We can already do a describe again. We could, by the way, also add it to the JJ new command here. But yeah, I'm gonna do it this way. Let's call it important change. And then let's modify the README file. This is an important text. And now we realize, okay, maybe your change wasn't that good. We need to make it clear that this is a very important text. So we should remove that again. Just pretend for a second that these were more complex code changes. And now at this point, we're going to realize, well, the change wasn't that important. Can we remove that one again? And that is where this auto-commit feature really comes in handy. I'm going to use a tool now called JJ UI, which is an open source tool you can find on GitHub. It's basically a command line text-based UI that helps you work with JJ. So you can see the normal JJ log here. And you cannot see it here at the bottom right because we zoomed in too far. But there is a so-called evolution log, which you can activate here. And then we can see all the things that we did within our commit. We can see that at the beginning we had an empty commit with no description set. Then it was not empty because we described it. And then we have the actual change. And we can go into these things and do diffs. And I just realized that I, of course, forgot to call any kind of JJ command before I did my second change. So that's the reason why it's not here. So it's not bulletproof for stupid people like me. But just for the sake of the demo, let's remove this one here again, call it JJ UI. And then we can see, OK, we had this addition here of some very important text. And if we go back and up one here, then we can see that we have only an important text. Good. As much I would love to explore more stuff in JJ, we only have about 15 minutes left. So we unfortunately need to move on. Check it out. It's an awesome thing. Change, extend. Lovely. Good. Let's quickly talk about Sapling. So Sapling was created by Meta, the company behind Facebook, Instagram, WhatsApp. And as we already know, Meta is rolling their own kind of version control system, as we discussed with this modified version of Mercurial. And Sapling is simply the newest addition in their tool stack in that regard. They open sourced it in 2022. And it generated big media coverage like this would be the next version control system. Didn't hear that about Jiu-Jitsu, unfortunately, because I think it's quite awesome. But the media coverage wasn't wrong. Sapling has some great potential. So we haven't heard much since that initial release, but development is still ongoing and still active, and they are basically committing new stuff each and every day. It's up there on GitHub. You can check it out. Initially, it didn't have a public available server component, but there is one now, which is called Monocake. The thing is, it's not ready yet. You can't use it, which limits the functionality of sapling, unfortunately, very, very much. You will see that in the demo in a second. But it supports Git. It's Git compatible. It supports GitHub, very deeply integrated. Unfortunately, not so much other version control system, like other application lifecycle management tools like Azure DevOps, GitLab, whatsoever. Good. The main target group for sapling is more on the side of huge code bases. It's coming out of Facebook, of course, or of Meta. And they have very big mono repos things. So it comes with things like a virtual file system. It provides faster checkouts, faster status commands compared to Git, for example, in that size, if you're working with such a big repository. But you, of course, can use it for smaller projects, smaller code bases too. The question is, should you? Well, it obviously introduces a lot of additional complexity. And as we heard a lot of today and yesterday, well, we shouldn't add always so much complexity. Feature-wise, otherwise it supports a lot of things that Jiu-Jitsu also has, so there is no need for local branches, there is no staging area, all that kind of things. And it allows you to reorder commits and stuff like that. And we're going to quickly check that one out in a demo too. How are we doing time-wise? Doesn't look too bad. Screen mirror, extend. Oh, not extend. Entire screen. There we go. Wonderful. So, sapling. Good. We're gonna go back here. This is my folder for Voxxed Luxembourg. Good. We're gonna clone a repository here with the SL command that is for sampling. And I have already tested it out here, so we have the full URL available. It's just some random GitHub repository that I created, which basically, whoops, go on. Voxxed sampling, which basically just contains a README file. And yeah, you already know the content of that one. So let's add something. Let's add a very important license file, or very open license, because we don't have one yet. Should do that with public repositories. And then we have a status command, where basically it's very similar to Git, feels a lot like Git, at least to me. There's also the add command to add this file now. So it says README is already tracked because I used the asterisk to just add everything because I'm lazy. But it basically added the license file now because so far it was untracked. Remember, there is no staging area as mentioned. And then we can simply commit that one here now, say add license. And if we execute only the SL command without any subcommand, by default, it will print you the log out here. And that's quite nice. It has a really nice representation by default. That's something I don't really like about Git, because the default git log command is very verbose. So you always need to add the --1 line if you want to have some nice overview. Yes, of course, you could create aliases and all that kind of stuff, but it's maybe not the nicest thing. Good. Let's create a couple of more commits here. I've already prepared this. It's not really that interesting, but basically just created 3 new files, added them to sapling, and then committed them. And if we execute that one now again, okay, we can see all the 3 new commits I just created. Let's check out the web interface. So sapling comes with a somewhat inbuilt web server, and that is the more magic thing behind it, because it also gives you some kind of UI that you can use. And there are some really nice features here, like edit stack. By the way, maybe zoom in a little bit. So we can see all the commits that we just created locally, and we can reorder them. Simply as that. We can simply remove one here, and then just click Save Changes, which is really awesome. but as mentioned, there is no real server component there just yet, so you can only do this locally at the moment. And I think so that is one of the biggest selling points for me for Sapling, and it's not available like as a tool, so you could use it on a centralized server. Good. So much about that. We can do a last execution of the SL command here to get the log, and you can see that one of the commits now is missing because, well, I removed it, and then you can see that 2 commits changed because, well, we just reordered them. Good. Extend. 10 minutes. Okay, we can pull this off. Good. Last but not least, we have Git Butler. It is a startup from Berlin and was founded by Scott Chacon. I don't think I pronounced it right. Google him, you will find him. He's one of the co-founders of GitHub. Git Butler supports, as its name already says, well, only Git. It's deeply integrated with Git. And it's a desktop UI client, but not just any new desktop UI client, because most desktop UI clients, at least for Git, go the way they just wrap around the available CLI commands and offer you those things in a nice way in the UI. Git Butler does not do that. They define development workflows in the UI and then later check out on how they can map them back onto Git, which is, I think, a really great idea on how to approach user experience and developer experience. Because I think we can all agree that Git sometimes isn't the most friendly version control system. It has a very steep learning curve. And that definitely helps. They also borrow a lot of ideas from Jiu-Jitsu. So the change ID we saw in the command line before, Git Butler has a similar concept. You don't really see it in the UI, but it's there in the Git objects. I saw a demo from them live in Berlin about 1 or 2 years ago, and it's really crazy what they're doing. They also have copied, borrowed, whatever, some other features, so you can also resolve conflicts later. They call it fearless rebasing in this case, and it also has a very rich project history where you just can revert back to stuff that you previously had. I think that's also something where Git is not the best at, because by default, if you try to revert a commit your very first time, you will find the revert command, and then you will realize that it will not, in fact, revert your commit, but revert it and create the revert commit, which might be somewhat unintuitive and surprising for somebody who had never to deal with Git. Good. Other special features, and that's the one I will be demoing because I think they're quite interesting, are virtual branches and dependent branches. So let's check them out in the demo. Good. We have to go to entire screen. Yeah. So there we already have a Git Butler folder. So that is a normal Git repository from GitHub that I just cloned. So you can also see the Git integration working here in the CLI. It didn't work for the other ones because they hide their Git repository in some other subfolders. In this case, my Git integration works because it simply is a normal Git repository. Good. So let's start up Git Butler. This is Git Butler. This is the UI. And, oh, well, they released a new version. Well, that wasn't there before. That's fine. Good. Let's do some changes. So let's modify the README again. Very important text. Blah, blah, blah. And we're going to also add the license file again. And if we go back to Git Butler now, you can see that we are on some arbitrary CS branch, which are my initials, automatically created that for me, and we would have 2 files here now. So that is something that often happens, I think, when you work on a ticket, because as we have heard today, the Boy Scout rule, leave the code base better than you found it. So I think it's important that you do refactoring when you're working on a Git, but that can be quite annoying for if you're doing code reviews. I mean, we have heard a talk today where they said they didn't do code reviews. I think most companies still do that. And I am not a big fan of just pressing approve because the pull request is so big. I would like to get smaller pull requests at least. And yeah, so what you can do here is simply drag the changes into a separate line. And those changes are now on a different Git branch. However, locally in our file system, both things are still there. So we basically have checked out 2 branches at the same time, which is a really awesome feature, I think, because I would have never thought about that, and it's really great. And we can start the commit process here. We're just gonna auto-generate some messages, and then we're gonna create pull requests. One here, one here. So if we open them here now, you can see that in both pull requests, we respectively only have the one change in there. So we basically worked on 2 branches at the same time, while both of them are still checked out here in the working copy, which is, I think, a really great and awesome feature. So let's merge those 2. It was modified. Ah, yeah, sure, we just merged it. Which one failed? This one worked. So, merge pull request. And then we can simply update our workspace here. Then do fully update once again. And now we're clean here again. So it removes the stuff because it knows, that we merged this kind of things because of this change tracking ID that I mentioned before. Okay, we have 3 minutes left. I think we have to skip the second demo here, otherwise we will run out of time. Basically, there are also dependent branches, so you can create a branch that is dependent on another branch, and it's really nice for merging stuff. Also, same scenario like you're doing a refactoring that you want to merge early, and then you're doing your feature that might take more time in development. Good. Let's go back. As we're wrapping up, we come back to the question, what comes after Git? We have seen 3 new contenders today, and all of them use Git or support Git in one or another way. We saw Titre using Git as a kind of storage engine. We saw Sapling being Git compatible besides its own protocol. And we saw a new Git UI that defines development workflows and then maps them back onto Git objects. So the answer to the question, what comes after Git, might be quite obvious. Maybe it's more Git. Even after 20 years, we are far from being done with Git. Git is still an amazing and great tool. It works with a lot of different workflows, and it is quite versatile. And all the 3 tools we checked out today use and support Git in one way or another. And we have seen similar things in the past in version control systems that basically built on top of each other. CVS was built around RCS. Subversion was the most compatible and successor to CVS. And BitKeeper reused the data structures and got a lot of inspiration from SCCS. So it makes them much more likely and much more practical to test and use them with existing projects. And an easy migration path, of course, is key for adoption. And using Git basically as a storage engine is, I think, a really great idea because Git is very good and efficient at encoding data and saving them. That's where most of the development efforts of the Git maintainers basically goes nowadays, make Git more efficient. So this makes them easy to integrate into existing projects and tooling. We have seen this GIF here a couple of times already. What are the next steps? What are we doing now? So obviously, you should go back to your company now and do something that I refer to as conference-driven development. Remove Git everywhere. You always use all these shiny new tools. Of course not. Please don't. I'm kidding. But I'm asking you to be open to explore some new things. Learn and experiment. Take some time, try out these new tools. A lot of them might not really be production ready at this point. Git Butler, I think, goes mostly in that direction of becoming more production ready. But yeah, it's still also an alpha or beta version. It has its problems. We saw the error message before, so it isn't 100% stable. But they're good enough to experiment with them. And especially if you check out Jiu-Jitsu, you will learn a lot of new things. It has a completely different mental model on how they do things. And it was really challenging for me, actually, to wrap my hand around these things. So Git might seem like the holy grail, as it is today, but there are other ways in life, too. And in our industry, rarely one size fits all. That's everything from my side. Thank you very much for your attention. And I think we have some time left for questions, if there are any. I see. You want to drink beer? Wonderful. That's a wrap-up. Thank you very much, Voxxed Luxembourg. I had a lovely time here. I hope you too. As my final act, as this was the last talk for today, please give a big, big round of applause to our organizers for creating this amazing event.